The Chinese remainder theorem is a type of question that first appeared in China in around, I think, around 200 AD, and you can recognize a Chinese remainder theorem problem. It's like a riddle where you say find a number so that, let's just say x, so that if you divide x by 11, you end up with remainder 3. But if you divide the same number instead by 7, you end up with something remainder 4. And the issue with it is that there's a lot of numbers that if you could divide by 11, you get remainder 3. 14 is one of them. It's 1 remainder 3. 25 is another. It's 2 remainder 3. 36 is another. And there's an infinite number of those. On the other hand, numbers that give remainder 4 when you divide by 7 are 11 is one of them. 18 is one. That's 2 remainder 4. 25 is 3 remainder 4. 32 is 4 remainder 4, dot, dot, dot. And as you can see, the number 25 is the answer to both of those questions. Now, this trial and error approach, making a list of all the numbers that satisfy each equation, that's okay for small enough numbers and when there's only 2 equations. But sometimes there's another condition. It also leaves a remainder 1 when you divide by 19, or even more conditions. And for that we need something better than just this trial and error. So I'm going to show you a process for the first day of this that works nicely for 2 equations. And it's going to specifically be for questions where the number I'm dividing by is prime. In modern notation, there's this shorthand for remainder, which goes like this. Like if I say 17, if you ever see something like this, 17, I'll just write it this way, 17 is equal to, here's a mod. If you ever see this expression, 17 equals 2 mod 3, this is a fancy way of saying, I'll say since 17 divided by 3, is 5, remainder 2. So this here is a fancy way of saying that if you divide 17 by 3, the remainder would be 2. And if we do that, we can rephrase this question as find a number so that if I divide by 11, I get remainder 3. And if I divide by 7, I get remainder 4. Sometimes it looks like this. Sometimes they put the mod 11 here. Still the same thing. Mod 7. And sometimes you even see a third line in the equal sign. Those are all equivalent for our purposes. I think I'll probably just use this notation for this question. What's going to help us answer this question is this chart. And if you're in my class, I have certain numbers filled in, but this is one where all the numbers are filled in. And this chart looks a bit like a times tables. But what the numbers mean, the reason that there is a here in my expression there's a 4 in column 3, row 11. The reason there's a 4 there is because if you take the number on the left, the row that it's in, and you do 11 times 3, and you multiply it, Oops, change that. The real reason that there's a 4 there is because 4 is the number you'd have to multiply by the column it's in. It's 3 times 4, which would get us 1 mod 11. So it's 3 times 4 is 12. 12 divided by 11 gives a remainder 1. Just for another example, the reason there's an 8 here is because 7 times 8 is 56, which is, if I divide by 11, the row that it's in, I get remainder 1. So every single number in this entire chart would be, you'd end up with remainder 1 if you divided the column it's in by the number there. If you divided the product, in this case like 19 times 3 is 57. If you divide 57 by 7, you will get remainder 1. So every single thing is like the special number that would cause us to get remainder 1. Now let's see how this chart can be used to answer Chinese remainder theorem questions. And here is the big instructive example. So our question is, we want to find a number that gives remainder 3 when I divide by 11, and at the same time gives remainder 4 when I divide by 7. And the answer is going to eventually be 25, because 25 divided by 11 is 2 remainder 3, and 25 divided by 7 is 3 remainder 4. Let's just see how the process goes, because there could be ones that have larger numbers, more complicated things, and I want to show you how to use this chart to do that. I'm going to make these 9 little slots to fill in. And when those numbers are all filled in, those 9 numbers, then we'll have the answer. We can I think I'll just show you what we can do. I'm going to first put the 7 here and the 11 there. And here I'm going to put the 7 and the 11. So I'm not using this remainder number yet. I'm not using this guy yet. I'm using the 11 and the 7. Now, I'm going to go to the 7 column, and I'm going to go to the 11 row. I'm going to see what number is here. And that number I'm going to put right here. And now I'm going to go backwards, and I'm going to take the 11. I'm going to take the 11 column and the 7 row, and I'm going to take this number and put that over here. Now, why I'm doing this will become more clear in a bit. 8 times 7 is 56, and 56 divided by 11 gets me remainder 1. That's the whole purpose of having the 8 there. But I don't want to have remainder 1 when I divide by 11. I want to have remainder 3. So I put this 3 in front of this one. Over here, 2 times 11 is 22, which if I divide by 11 gets no remainder. But if I divide by 7, I get remainder 1. But I don't want to have remainder 1, so I put a 4 here. So at this point, this number is 168, and this number is 88. And the sum of those two numbers is 256. So let's see what we know about the 256. if I divide 256, well, first of all, 256 is an answer to this question. If you divide 256 by 11, you will get remainder 3. If you divide it by 7, you will get remainder 4. So I'll just start by saying that. But the reason that happens is if you look at the 168. You see, if you divide 168 by 11, you're definitely going to get remainder 3. And that's because 8 times 7 gives you remainder 1 when you divide by 11. But if you multiply it by 3, it changes the remainder into 3. On the other hand, this other term, 88, that has no remainder when you divide by 11. So adding it to the 168 doesn't change the fact that the remainder is still going to be remainder 3 when you divide by 11. And that's why 256 is remainder 3 when you divide by 11. On the other hand, if you divide 168 by 7, you'll get no remainder because 7 is one of its factors. But if you divide 88 by 7, well, 22 divided by 7 is remainder 1, and then this 4 here turns it into remainder 4. So if I divide 88 by 7, I get remainder 4. Divide 168 by 7, I get remainder 0. So the sum of them, 256 again, is remainder 4 when I divide by 7. And that's why 256 is an answer, but it's not the smallest answer. Because if I subtract away 7 times 11, which is 77, I will get an answer that's smaller than 256, but also has remainder 3 when I divide by 11 and remainder 4 when I divide by 7. Because subtracting a remainder of 11, a remainder of 7, subtracting a multiple of 7 does not change the remainder when you divide by 7. And subtracting a multiple of 11 doesn't change the remainder when I divide by 11. And since 77 is both, 256 minus 77 is 179. And just to check, 179 divided by 7 is 20, whoops, 2, this was 39, 25, remainder 4, which is what I was hoping, and 179 divided by 11 is 16, remainder 3. But I could do even better by subtracting 77 again and get 102, which is also an answer, and I could subtract 77 again to get 25, which is the smallest possible answer. Can't subtract 77 again. But the sneakiest way to do it is to instead just divide 256 by 77, and you'll get 3 remainder 25. The 3 goes here, the 25 goes there, and that's the answer. So that's how all these questions work. If you have this chart, the chart's used for getting these 3 numbers. Sorry, the chart's used for getting those 2 numbers. And everything else comes from either the remainders or the things I'm dividing by. This is both of the things I'm dividing by, and this 3 came from here. And the answer is the remainder for that. Well, it is pretty confusing, but I do want you to think about when we look at this expression, the 3874211. Let me just write that one down. 3874211. 3874211 minus 3711. If I look at this expression and I divide it by 7, this term and this term are not going to contribute to the remainder. Only this term will. But since 2 times 11 is remainder 1 when I divide by 7, and I throw the 4 in there, I end up with remainder 4 when I divide by 7. On the other hand, if I take this and instead divide by 11, this term and this term have 11s in them, so they don't alter the remainder. Only this term matters. But since I put the 8 here from the chart, 8 times 7 is remainder 1 when I divide by 11. And if I throw the 3 in front of it, it changes it into remainder 3. So that's kind of why this works, and that's this video.